Ready? These are also systems, but what's different about them? They're inequalities, right? So a second ago we were looking at y equals lines, and we were just drawing two lines and telling where they cross, right? What do you have to do differently to graph one of these? You have to shade, right? You have to shade, you have to do the dotted line, the solid line. This is from last week, whatever day that was, Wednesday that we did this lesson. Okay. So if I'm going to graph y is less than or equal to x plus 4, y-intercept of 4, right? Slope of 1, so up 1 over 1. Now actually on this one I ran out of room. What else could I do if I run out of space here? Macy?
-1.
Yeah, really your slope right now is 1 over 1. Couldn't I pretend that was -1 over -1? Because that would still make a positive 1, so I could go down 1 and over 1. Am I drawing a dotted line or a solid line here? Solid, yep. And then which way am I shading for that first one? Above or below? Okay, I can't hear you if you're mumbling it because there's trucks, but it's below. That's less than. So I'm going to shade all that. Okay. So remember, this line represents all the places where y is exactly equal, because they thought we needed that this morning. The line represents all the places where y is exactly equal to x plus 4, and then the shading is all the points where y is less than x plus 4. So this time, instead of just having a single line to worry about, we have all of these points that are technically solutions to that. Okay, so there's way more solutions to an inequality than there are to an equation. Now let's look at the second one. Where's that graph going to start? 0, 0. My slope is -2 over 1. So that's down 2 and over 1. Down 2 and over 1. And then what kind of line am I drawing? Solid. And then am I shading above or below? Above, because that's greater than. You want to make sure you go everywhere above the purple line, so all of this. Do you see that I get this area in here? Like this V on your graph is double shaded. These are the points that are solutions to both of these at the same time. And so technically that's your answer. You're not saying like a specific point here, because there's lots of points. Whereas before you were just having two lines cross and saying it's that one specific point. Here what you want to do is after you graph that and you see where that double shading is, I would kind of darken in that area that's double shaded just so you can see where it's at. So all of this is your solution. These get kind of messy looking, but okay. So with these, pretty much you're always going to have like two lines crossing on your graph somewhere. And you'll shade both of them and you'll end up with one section that is double shaded. And that double shaded section, that's your solution. Okay? Now if you look at the directions, it says identify 2 points that are solutions and identify 2 points that are not solutions. Where am I going to find my solutions? In that double shaded, right? So I want to pick any point that's in there. Somebody name a point that's in the double shaded part.
2, 3.
2, 3 would be 2, 3, yep. So 2 3s right there, that would be a solution.
1, 1.
Good. 1, 1 would be here. Okay, so there's 2 points that are in the solution. Could you pick others?
Yes.
Yeah, you can pick anything you want. Anything in that double shaded region. What if I asked you to pick points that were not in the solution?
-4, 5.
Sure, anywhere else, right? So -4, 5. Not part of the solution. Well, maybe. Oh, I guess I drew my line a little off. You're right. -4, 5 would not be part of it. If that's a solid line, remember the line itself counts as the solution, but I think I should have actually, my line should have been a little more angled upward. So that's fine. Pick another point that's not in the solution.
-2, -4.
Okay, -2, -4. So yeah, anywhere that's not double shaded. Good? Tough stuff there at all? Okay, let's do the next one. Y is less than or equal to 1/2 x plus 1. Where's that going to start?
1.
1. And then slope is 1 over 2, so up 1 and over 2. Up 1 and over 2. Solid line or dotted? Yep, solid. Actually, I'm going to do a couple this way just to keep my line straight. Solid line. I would shade as you go. I have some people who try to draw both lines and then figure out the shading, and that can get confusing. So this is y is less than, so I'm going to shade everything underneath. Now that next one is not in slope-intercept form, so a little harder to graph. I would just use your intercepts. What's the x-intercept going to be on that one? 3, because if you put 0 in for y, you would have x equals 3. Okay. And what's the y-intercept going to be? If you put a 0 in for x. You put a 0 in for x, your y is also going to be 3, yeah. Dotted line or solid? Dotted this time, good. I'm connecting these 2 points with a dotted line. And then remember, these ones, if they're not in slope-intercept form, you've got to use a test point to figure out which side to shade on. I'm going to choose 0, 0. So if I plug in 0 and 0, is this a true statement? See what I'm saying? If I put 0 here and 0 here, is it true that 0 plus 0 is less than 3? Yes, so which side do I want to shade on? The side that has 0, 0 or the side that does not have 0, 0? Has 0, 0, because that's true, right? 0, 0 is right here, so I'm going to shade this side of my purple line. And then again, do you see that V that you have double shaded down here? This is where you would kind of darken it in and say this whole thing is my solution. Okay. Macy?
So you can pick like any point on the graph, like you pick 0.
To test it? Yeah. Yeah, you can pick anything as long as it's not right on the line. And then what you do is you plug that test point in. If it comes out to be true, you shade on whatever side that point is on. If it comes out to be false, you shade on the opposite side. Okay? Okay, so pick a point that's part of the solution. Pick a point somewhere in here.
0,
0,
0.
0, sure. 0, 0 is in there. What else is in there? 2, -2. Gonna be about there. That's right, 2, -2. All right, tell me something that's not part of the solution.
4, 5.
4, 5. You're right. 4, 5 would be way up here, not part of the solution. And another one that's not part of the solution. 1, 4. 1, 4. Yep, not part of the solution. Good. Let's try one more of those, and then we'll be done. Okay, y is greater than 3x minus 4. Here's -4. My slope is 3 over 1. Okay. What kind of line am I drawing here? Dotted line. Good. And shading on which side?
Top.
Yep, greater than, so that's the top. That's all this. Okay. How am I going to go about graphing that next one? Okay, so Haley, what did you just say? Okay, yeah, we could do that. Back here I use the intercepts, but if the intercepts freak you out, we can do slope-intercept form. That would look like this: 2x minus 5y. What is it right now? Is greater than or equal to 20. Subtract the 2x. It's negative 5y, greater than or equal to negative 2x plus 20. And then the only thing you have to be careful of with inequalities, if you're going to put them in slope-intercept form, right here I'm dividing by a negative 5. So what's going to happen? Yeah, the inequality sign is going to flip because you're dividing by a negative. So you're going to get y is less than or equal to, this here would just reduce to positive 2/5. And then 20 over negative 5 is negative 4. So then I'm going to go to my y-intercept, which is negative 4. And my slope tells me to go up 2 and over 5. That's a weird one. And I guess I could also go down 2 and over 5. It's going to be down here somewhere. I'm going to shade, or I'm going to do a solid line. And which side of this am I shading? Underneath, right? Because it's less than up here. So I'd be shading all this. And it's a little bit hard to see in this one because it kind of goes off your graph. But can you see this section that would be double shaded? It would be this little V down here. Up to that line. Okay, that's your solution in there. So name me a point that would be part of the solution. Hard to see, but there are points down there. How about -1, -5? Does that work? Let me ask you this. What about -6? No, sorry. -5, -6. Would that work? -5, -6 is this point right here. Is that part of the solution? Yes, it is. But is the point, oh, let's see. What would my next one be? -1, -7 would be the next point on this line. Would this line be considered the solution? Why not? I see lots of head shaking. Say it again. It's a dotted line, right? So that dotted line, those points are not included as part of your solution. Okay? So what did I just say? -1, -7 would not be part of the solution. Or you could pick any, like 0, 0, not part of the solution. Okay? Does that make sense? How are you feeling on that? They're both, really both lessons are just graphing two things at the same time. On this lesson, you really don't have to give an answer. It might ask you a question like this where it says pick 2 points or something like that. But if it doesn't ask you that, you just draw the graph and leave it there, and the graph is all you have for your answer. Back here on this one, you did have to say the specific point where the lines cross. Like you had to name it as a coordinate. Okay? That's what I mean when I say the solution. The solution is the one coordinate that they share in common. Good?